All right, so we are on the last one. Multiply two matrices together. Now this will take us a little bit of context to understand why it works the particular way it does. And so what I'm going to do is I'm going to give you kind of a general description of how this is going to work, and then I'm going to use context to try and explain the mechanism behind it. Okay, so when we multiply two matrices together, there's a very specific structure that has to happen. Okay, when you're doing matrix multiplication. Okay, so when you have one matrix times another matrix, okay, I'm going to use capital letters to represent the matrices. This one has a certain number of rows and a certain number of columns, and that can be any two numbers. In order to multiply it times matrix B, the columns from the first matrix has to be the same as the rows in the second matrix. Again, these two numbers, the columns from here and the rows from here, must match. These two can be different. And what we will find is that the product, A times B, the size of the product will actually be the rows of the first one and the columns from the second one. That's the size that we will get. However many rows the first one had and however many columns the second one had. Now that may see, when I would see that, I would think, what in the world? Where is this coming from? So let me show you an example and see why this is so. So this is an example from your textbook. It's just what I was talking about just a second ago. We are doing a housing development. Okay, if you look at this picture, you have two different styles of home. One is colonial and one is ranch. So we want the neighborhood to look not exactly the same. Over here, you'll notice that these numbers in this matrix, 30 plus 20 plus 20 plus 20 plus 10, adds up to be 100 homes. So if you look at, there's going to be 30 colonial homes, if you add those up, and there's going to be 20, 40, 70 that are ranch. So you can see most of them will look like this brick home, but 30 of them will mix it up and look like this colonial. Now, model X, Y, and Z are different ways of arranging them, meaning that you might put the garage on the other end, you might put the kitchen at the front or the back. So there's 3 different ways, so that gives us the 6 different possibilities. There's going to be 30 model X, there's going to be 30 model Y, and 40 model Z, so kind of an even distribution there. Now this matrix, matrix A, is telling us about the number of each type of homes, and it has 3 rows, model X, Y, and Z, and 2 columns, so colonial and ranch. Now, the second matrix here looks at the different amount of supplies necessary for colonial and ranch homes. Colonials need much more lumber, okay? They're built mainly from wood. And so you can see that when it comes to lumber, it needs twice as much wood. But ranch are brick homes, and so you can see that the ranch needs 20 times the supply of bricks, no bricks needed for the colonial, and 5 times as much concrete, much more sturdy house, like in the 3 Little Pigs, right? This is like the second and the third pig, there's no house of straw here. Now notice that this one has only 2 rows. There's colonial or ranch home, but there's 4 types of supplies. Now what we're going to do is we're going to multiply these together, meaning we're going to use the 2 types, colonial and ranch, colonial and ranch, colonial and ranch, and I'm going to combine them. And what that matrix is going to tell me is it's going to tell me for models X, Y, and Z how much concrete, lumber, brick, and shingles will be needed. So I'm going to look at the entire thing together. All right, so how do I do that? So A times B. It's going to be a 3 by 4 matrix. So I'm going to set this up. So my 3 rows are going to be models X, Y, and Z. And my 4 columns are going to be concrete, lumber, brick, and shingles. Look at my abbreviation, I'm amazing. So how does this work? Well, let's look at Model X, okay? Model X. So for this first spot right here, I have two different numbers for Model X, 0 colonial and 30 ranch. And when I look over here, the amount of concrete, it takes 10 concrete for colonial and 50 concrete for ranch. So what I'm going to do is I'm going to multiply those together, 0 colonials that take 10 and 30 ranch that take 50. And what you should notice is that the 0 and the 30 here are each multiplied with the 10 and the 50 here. And then I find the sum by adding them together. That's 0 plus 1,500. So I'm going to need 1,500 units of concrete for all the Model X. Now, as I move throughout, I have to do that for lumber, brick, and shingles, and I have to do it for X, for Y, for all the Model Y, and all the Model Z. I'll do a couple more, but not the whole thing. Okay. So you can move across or you can move down. So if I move down, now I'm talking about Model Y. Whoops. Model Y has 10 colonial and 20 ranch. So that would be 10 colonial times 10 units of concrete plus 20 ranch times 50 units of concrete. That's 100 plus 1,000, or 1,100. And my last one would be look at Model Z. Come on now. There we go. Model Z is 20 and 20. So 20 colonial that use 10 and 20 ranch that uses 50, or 200 plus 1,000. Now, when I move to the next, oh, come on, we can do it. When I move to the next, when I move to lumber, I've got to go back and repeat that for Model X, Y, and Z again. But now, I'm going to move over and talk about lumber. 2 units for colonial and 1 unit for ranch. So I've got 0 colonial times 2 plus 30 ranch times 1. And you can kind of see how we're going to fill this in. Move that down again. I wish I could just grab this. There we go. 10 colonial that need 2 units and 20 ranch that needs 1 unit. That's 20 plus 20. So you might pause it right here and see if you can fill in the rest. And this is what we should end up with for the total at the end. All right, when we multiply them together, this is our matrix AB, and it is 3 rows by 4 columns.